more clumsy today than usual because I need to adjust this board a tad bit. My apologies. So let's get a bit more sophisticated. Determine how many subdivisions of this interval are needed to guarantee that S of n approximates this definite interval to within this many units. Excuse me. Well, our error formula says this. In absolute values, using n subdivisions with S symptoms is going to give you an error that's bounded above by some constant k times b minus a to the n, to the fifth, all divided by 180 times n to the fourth. But I want a guarantee that this error is bounded above by, I think, this many units. I think that's what I had on the other side. Tens, 100,000, 10,000, 100,000. Now, I am a bit stuck in the sense that I do not know what K is. So I need to take a break and find out what K is. So for me to do that, let me pull out a nifty piece of scratch paper. Here's the function in the integrand's position. Now that K is an upper bound for the absolute value of the fourth order derivative over the interval from A to B. So let me compute the fourth derivative function. Now, if I'm trying to find the absolute max in absolute values of this fourth order derivative function over a closed interval from e to the negative 2 to 1, then I need to evaluate this fourth order derivative function at the endpoints. But also, I need to evaluate it at any critical number c for this fourth order derivative function. For me to find a critical number, I need to compute the fourth order derivative's own derivative, find out when it's undefined or equal to 0, at least over my interval. So let me take a break and compute that fifth derivative function. But I think the critical number I generate, the only critical number I'm going to generate is I'm kind of awkward. I'm stalling for a minute because technically speaking, this is undefined when x is equal to 0. But let's not worry about that. That's my interval anyways. So let's just see if I can find out when this fifth order derivative function is equal to 0. But that's going to happen when x equals this. That's a 154 over 120. That's outside my interval, so I don't need to worry about it. So it looks to me like I don't generate a critical number for the fourth order derivative function over my interval. And so let's just evaluate these. Oh, maybe that won't be very quick. Yeah, it is. This one, I am afraid, is not quick. So it looks to me like the endpoint in absolute values that's the largest is this one. That'll be my K value. Now, solving this inequality for n to the fourth. My eyes are so bad. But that tells me this. Taking the fourth root of that number. So that means n has to be chosen at least as big as 20. The next higher natural number is indeed even, so I'll keep it. So it looks to me like to guarantee that desired accuracy, I do need to have at least 20 subdivisions so that census rule approximates that definite interval within that desired error.